Hello students, I am Aparna Vidhate from DAS Brihan Maharashtra College of Commerce Pune. I teach mathematics and statistics to the students of 11th and 12th standards. We have started matrices. In matrices we have done already how to find inverse by using adjoint method as well as by using elementary transformations. In this class we'll see applications of matrices, in that reduction method and inversion method. Let us start with the PowerPoint presentation. To find inverse by using adjoint method, let us see how many steps are there. In this method, we should know the definitions of minor and cofactors. In particular, minor of an element A11 of matrix is the determinant obtained by ignoring first row and first column. Minor is denoted by M11. So minor is related to every element of an matrix. Cofactor of an element A11 of a matrix is A capital A11, which is equal to minus 1 raised to 1 plus 1 M11. So related to every minor there is a cofactor. After that, getting all cofactors, write down the adjoint of a matrix. The transpose of the cofactor matrix of A, it is denoted by adjoint of A. And the last step is formula, that is A inverse equal to 1 upon determinant A into adjoint of A. So while finding inverse by adjoint method, first of all find determinant of A, then find minors, then find cofactors, write down the matrix of cofactor, and then write down adjoint. Adjoint is nothing but the transpose of the matrix of cofactors. So we'll see example related to this. Here is the example. A is a matrix of order 2 cross 2. Then find A inverse by the adjoint method. In the examination, there is a question depending upon A inverse. Find A inverse by using elementary transformations or by using the method adjoint method. So whatever question is there, you have to apply that method only. If it is asked for elementary transformations, then use elementary transformations. If it is asked by using adjoint method, apply adjoint method. Here, given A, first of all find determinant of A. Determinant A is equal to 19, so which is not equal to 0. That means given matrix is a non-singular matrix and therefore A inverse exists. Related to each element here, we have to find minors and cofactors, because we have to find matrix of cofactors to get adjoint of A. So here are the elements of A. A11 is 2, A12 is minus 3, A21 is 3, A22 is 5. Related to each element, minors of A are M11 is 5, M12 is 3, M21 is minus 3 and M22 is 2. So depending upon these minors, cofactors are capital A11 is equal to minus 1 raised to 1 plus 1. Wherever we have a exponent even, then the value is positive. So into M11, that is 1 into 5 is 5. A12 is minus 1 raised to 1 plus 2. M12, which is equal to minus 1 into 3 equal to minus 3. Then A21 is minus 1 raised to 2 plus 1 into minus 3, which is equal to 3. A22 is minus 1 raised to 2 plus 2 into M22, which is equal to 1 into 2 is 2. So here cofactors are 5, minus 3, 3, 2. So write down the matrix of cofactors. Matrix of cofactors equal to 2 cross 2 order matrix with rows 5, minus 3, 3, 2. Then adjoint of A is equal to transpose of matrix of cofactors, which is 5, minus 3, 3, 2 transpose, and therefore adjoint A is equal to 5, 3, minus 3, 2. To get transpose of a matrix, just you have to change the places of rows and columns. A inverse equal to 1 upon determinant A into adjoint A. Therefore, A inverse is equal to 1 upon 19. 19 is determinant of A into 5, 3, minus 3, 2. So this is nothing but the A inverse by using adjoint method. We'll recall all the steps one more time. While applying adjoint method, first of all find determinant A, check whether it is 0 or non-zero, then get the minus, then find cofactors related to each element of a matrix A, then write down matrix of cofactors, then write down adjoint of A. Adjoint is nothing but the transpose of matrix of cofactors, and then write down the formula and substitute determinant and adjoint of A in the formula to get the A inverse. So here is the A inverse. Then we have last part from the matrices, that is applications of matrices, which is a important part of matrices. Applications of matrices include a solution of simultaneous linear equations. So first of all, what is mean by simultaneous system of linear equations? Here is for 2 cross 2. Consider a1x plus b1y, which is equal to c1, a2x plus b2y, which is equal to c2. The 2 cross 2 matrix formed by coefficients of x and y. Here is a1, b1, a2, b2, x is column matrix xy, and b is matrix of constant c1 and c2. So the system is ax is equal to b. Write down the matrix form first of all. This is the matrix form of simultaneous linear equations. So writing matrix form is important part of system of linear equations. Example, if we have two linear equations in two unknowns, 3x plus 5y which is equal to 2 and minus 2x plus 5y equal to 5, then the matrix form is ax equal to b. So write down the given system in matrix form. Second example is for three linear equations in three unknowns. So here is the matrix form of the linear equations. You'll see here A is nothing but the matrix of coefficients. Then we have a column matrix x, y, z which is equal to matrix of constants. In the examination, to write this matrix form, you have a 1 mark. Then to get the solution of system of linear equations, there are two methods. First method is method of inversion, and then second method is method of reduction. Let us start with the first method, method of inversion. Name itself suggests us that we have to use inverse in this method. First step is consider a system of linear equations. Second, express it in the matrix form as ax equal to b, where A is non-singular matrix. In third step, pre-multiplying ax equal to b by A inverse, we get A inverse ax which is equal to A inverse b. Write down A inverse A in one bracket into x which is equal to A inverse b. We know that A inverse into A is nothing but the identity, and therefore equation is Ix equal to A inverse b. Therefore x is equal to A inverse b. Thus there is a unique solution for this system. Let us do the example depending upon inversion method. Question is like this: solve the following equations by the inversion method. Even in the examination, if it is asked for inversion method, you have to apply inversion method only, and if it is asked by using reduction method, you have to use reduction method. This example is of 4 marks. There are two linear equations in two unknowns, 4x minus 3y which is equal to 2 and 3x minus 4y which is equal to minus 6. Therefore, A is 4 minus 3, 3 minus 4. X is column matrix xy and B is matrix of constants 2 minus 6. Write down this in a matrix form as Ax equal to B. After pre-multiplying by A inverse, we have this reduced system as x is equal to A inverse B. Then to solve for x, we need A inverse. So to get A inverse, you can apply any of the method. For that means you will be able to apply elementary transformations or by using adjoint method. In this example, I have used adjoint method to get the A inverse. And now you know that how to find A inverse by using adjoint method. So first of all, find determinant A. In this case, determinant A is -7, which is not equal to 0. Therefore, A inverse exists. Then find minus n cofactors. Here are the minus n cofactors of this matrix A, where minors are -4, 3, -3, 4, and related cofactors are -4, -3, 3, 4. After getting cofactors, write down the matrix of cofactors, which is -4, -3, 3, 4. Then adjoint is nothing but the transpose of matrix of cofactors. So adjoint A is here -4, 3, -3, 4. And therefore, A inverse is equal to 1 upon determinant A into adjoint A. And A inverse is 1 upon 7, 4 minus 3, 3 minus 4. From equation number 1, x is equal to A inverse B, which is the reduced system. And here, to get the value of x, we have to substitute A inverse and column matrix B. So if we'll see here, we have to multiply these two matrices. Then we'll get x is equal to 26 by 7 and 30 by 7. So by equality of matrices, x is 26 by 7 and y is equal to 30 by 7, which is nothing but the solution of system of linear equation. So 4 marks distribution is, first of all, first mark is for writing the given system in matrix form. Then the second mark is for A inverse. Then third mark is for writing system x is equal to A inverse B. And then fourth mark is for x and y. That is for solution. Then here are some important points while applying inversion method. It is necessary to write matrix equation, convert x is equal to b in x equal to A inverse b. If you feel adjoint method is easy to get inverse, you can use adjoint method. Getting inverse is important step in inversion method. After finding answer in column matrix form, don't forget to write x, y and z values. The method which is asked in the question, use only that method. That means if it is asked inversion, use inversion method. If it is asked reduction method, then use reduction method. Then here is the rule for reduction method. Again, in case of method of reduction, name itself suggests us that we have to reduce matrix A. Write given linear equations in the matrix form as Ax equal to B. Then apply suitable row transformations on the matrix A to reduce it into an upper or lower triangular matrix. We know that what is meant by upper triangular and lower triangular matrix. Same row transformations are performed on matrix B. Then rewrite the equations in the form of system of linear equations. This step is after getting upper triangular matrix or lower triangular matrix, we have to rewrite the equations in the form of system of linear equations. And then we know that how to solve system of linear equations simultaneously to get x, y, z. So let us see one example here. Solve the following equations. 2x plus y equal to 5 and 3x plus 5y which is equal to -3 by the method of reduction. Equations are these two equations. First of all, we have to write in the matrix form Ax equal to b. So we know that how to write in a Ax equal to b form. 2, 1, 3, 5 column matrix xy and which is equal to constant of matrix 5 minus 3. Now to reduce A into an upper triangular matrix, we know that we want below diagonal elements are zeros. So here is the row operation. First of all, we have to make A11 place 1 because at 3 place we want 0 here. So if we'll apply row operation, R1 changes to R1 by 2. After applying this row operation, we'll get 1, 1 half, 3, 5 and on the right hand side it's a 5 by 2, 3. Then at 3 we want to make it a 0. So to make 3 to 0, we have to apply row operation as R2 changes to R2 minus 3 times R1. So first of all, multiply by 3 to R1 and then subtract that element from the R2. Then we have 1 half 0 7 by 2 xy 5 by 2 minus 21 by 2. Now here if you'll observe, our A is reduced to an upper triangular matrix. All below elements are 0, below diagonal elements. Then after reducing to upper triangular matrix, we have to rewrite the given system in system of linear equations. So observe matrix A is reduced to upper triangular. Now we can write equations as x plus half y, which is equal to 5 upon 2, which is equation number 1, and 7 by 2y, which is equal to minus 21 by 2. Now these two equations are simple system of linear equations. You can solve this simultaneously to get the values of x and y. So from equation number 2, value of y is y equal to minus 3. Substitute y equal to minus 3 in equation number 1 and solve for x. So here is the value of x. X is equal to 5 by 2 plus 3 by 2 and x is equal to 8 upon 2. Therefore, x is equal to 4 and therefore, system has solution like x is equal to 4 and y is equal to minus 3. So this is nothing but the reduction method. We'll recall again the steps of reduction method. In the reduction method, first of all, write down the system in Ax equal to B form. Then reduce A to upper triangular or lower triangular matrix by using elementary transformations. You can use elementary row transformations to reduce. Then after reduction, you have to rewrite the system in again linear equations form and solve those linear equations simultaneously to get the values of x, y, z. So this is nothing but the applications of matrices. Let us do one more example for method of reduction. Here we have three linear equations. The matrix equation is Ax equal to B. You can see here A is nothing but the matrix of coefficients of x, y, z. Here in this case, we have to apply row operations to get the zeros at R2 and R3 place. So here you can check R2 changes to R2 minus twice R1 and R3 changes to R3 minus R1. Here already A1 place is 1, so no need to make it 1. Then we have, after applying these two independent row operations, system is changed to 1 minus 1 1, 0 3 minus 5, 0 2 0, x y z, and right hand side is 4 minus 8 minus 2. Then add 2 below 3, we want to make it a 0. Therefore, R2 changes to R2 by 3 is the row operation. To get A2 tooth place 1, then only we'll be able to make 0 at tooth place. So here is the system 1 minus 1 1, 0 1 minus 5 upon 3, 0 2 0, and right hand side is 4 minus 8 by 3 minus 2. Now you can guess at 2 we have to make it 0. So what will be the row operation? Can you guess here? The row operation is R3 changes to R3 minus 2 times R2. Yes, here is the row operation, and after applying this row operation, we have system as 1 minus 1 1, 0 1 minus 5 by 3, 0 0 10 by 3. Since in this matrix we have a P by Q form, it's okay. After solving these equations, you will get simple form. So if we'll check here, below diagonal entries are zeros, and therefore this is nothing but the upper triangular matrix. Let's rewrite the system of equations. Again, x minus y plus z equal to 4, equation number 1. Y minus 5 by 3z equal to minus 8 by 3. And the last equation is 10 by 3 z, which is equal to 10 by 3. So from equation number 3, z is equal to 1. Put z in equation number 2 and solve for y. So y is equal to minus 1 and put y and z in equation number 1 and solve for x. Therefore, x is equal to 2. And after that, solution is x is equal to 2, y is minus 1, and z is equal to 1. I hope this is very simple method. So, for applications, we have done two methods. One is inversion method, other is reduction method. Here are some important properties which we are going to use while solving MCQ type of problems as well as for fill in the blanks. Let us recall some properties from the chapter. Singular matrix means determinant A equal to 0. Non-singular matrix means determinant A is not equal to 0. A transpose is equal to A. If A is a symmetric matrix, then A equal to A transpose. If B is a skew symmetric matrix, then B is equal to minus B transpose. Determinant A equal to determinant A transpose. A plus B transpose equal to A transpose plus B transpose. And for product, it's different. AB whole transpose is equal to B transpose first and then into A transpose. Then multiplication is not commutative, means AB is not equal to BA. This property is important property, so do not confuse with this. Then we have A plus B whole square, which is equal to A square plus AB plus BA plus B square. Here A and B are matrices. Then this is for subtraction. A minus B whole square, which is equal to A square minus AB minus BA plus B square. Then KA transpose, which is equal to K into A transpose. Here K is nothing but the scalar. Then this is an important equation. A into A transpose is equal to identity, which is equal to A inverse A. If you remember, this equation we use to get A inverse by using elementary transformations method. Then we have A is a square matrix, then A plus A transpose is symmetric and A minus A transpose is skew symmetric. For 2 cross 2 order matrix, general matrix ABCD, adjoint of A is just you have to change the places of diagonal elements, and off diagonally you have to attach negative sign. So depending upon these properties and whatever we have done in last classes, let us do some alternative problem. Here is the matrix 6 0 0 0 6 0 0 0 6 is dash. Options are identity, scalar matrix, null matrix, diagonal matrix. Clearly you can see here it's a 3 cross 3 order matrix, and diagonally we have all equal elements. That means it's a scalar matrix. So the option is B, scalar matrix. Adjoint of A. Just now we have done, if we have a is equal to ABCD, then how to get the adjoint of A? Diagonally we have to cross the elements and then off diagonally attach negative sign. Can you guess here what is the option? Yes, option is C, minus 9, 5, minus 2, 4. Okay, here is A, which is a scalar matrix. Diagonally we have 5, 5, 5. Then we have to find determinant of adjoint of A. First of all, let us see the rule. What is the adjoint of A if the given matrix is a scalar matrix with A, then you can find adjoint of B here is A square 0, 0, 0 A square 0, 0, 0 A square, and therefore determinant of adjoint of B is equal to A raised to 6. Even here we can apply one property, that is, if we have a triangular matrix, then determinant of a triangular matrix is nothing but the product of diagonal elements. Therefore, in this case, it's a triangular matrix and therefore determinant is A square into A square into A square, which is A raised to 6. If we'll apply this property to the example number 3, we have a option as 5 raised to 6. It's an interesting example. If we have a 3 cross 3 matrix B, which has its inverse equal to B. That means B inverse equal to B is the case. Then B square equal to what? Let us check. We know that from the given B into B inverse equal to identity, but we have B inverse equal to B. Therefore, B into B equal to identity. That means B square equal to identity, and therefore the option is B, identity matrix. If A is a non-singular matrix, that means determinant A is not equal to 0, then find determinant A inverse. Let us see. We know that A into A inverse equal to identity. Apply determinant on both sides. Determinant A into A inverse equal to determinant identity. Therefore, determinant A into determinant A inverse equal to 1, as determinant I is 1, and therefore determinant A inverse equal to 1 upon determinant of A, and therefore the option for the fifth example is D, 1 upon determinant A. I hope you are enjoying these MCQs. If A and B square matrices of order n cross n such that A square minus B square equal to A minus B into A plus B, then which of the following will be always true? We have done this already, how to solve this property. And here you have to use multiplication of is non-commutative. So AB is not equal to BA, but in this case we have, after solving this property, AB is equal to BA, and therefore the option A is AB is equal to BA. Next, seventh example. A is 2 cross 2 order matrix such that A into adjoint of A, which is equal to 9 0 0 9, then determinant A equal to what? Here are the options. Option is C, 9. Why? Let us check. We have one important property which is not mentioned in the textbook. Property is A into adjoint of A, which is equal to determinant A into identity equal to adjoint of A into A. Even you can check this property for particular example. Take A as one matrix and then find adjoint of A and check this property whether it is true or false. Here is A into adjoint of A, which is equal to 9009. If we'll take 9 scalar common, then we have 9 into identity, and therefore if we'll compare with this property, we have a 9 as determinant of A. Here is the simple example. Two matrices A and B are given with 2 cross 2 order. A is 1 2 minus 3 minus 2. B is 0 minus 1 5 4. Yes, matrix multiplication is possible, and this example you have to do for homework, like find the product of two matrices. I hope this is sufficient for you. Do the practice of more examples of MCQs as well as fill in the blanks. Then solve more examples from the miscellaneous to get the practice. Okay students, in this class we have covered applications of matrices. In that, two methods we have done. One is reduction method, other is inversion method. So do not confuse with the methods. In the examination, whichever method is used, you have to use that particular method. If you confuse with the method, you will not get full marks in that. Applications of matrices is very easy. Do the practice of more examples from miscellaneous. Thank you very much.